For number 20, what I want to do is look at the equations of these lines and the inequalities. So let's start with the line. In my y equals, I have negative 1/2 x plus 1 and then x minus 5. It looks like they intersect at one place. That means they have one solution. Now, the negative 1/2 x, if I shade this above because it says greater than, and for this one, if I shade below because it says less than, it looks like I have an infinite amount of solutions in this little region. So the systems of equations has more solutions. Let's see, they both don't have infinite. The system of equations has more, and that's not true. The system of inequalities has more solutions. For number 21, the answer is number 4. Which function below is equivalent? So remember, to test for equivalency, you can plug in a number for t, evaluate it, and then see which of those 4 choices gives you the same thing. Well, to explain number 4, choice number 4, let's go back to multiplying like bases. When you have like bases, you have to add the exponents. Well, what if I gave you m to the, I don't know, c plus d, and you had to go backwards? You would say m to the c times m to the d. So this is basically what's happening right here. I have 1.013 to the t times 1.013 to the 25. Why did I separate it like that? Because there's a plus sign, much like I have right here. A lot of the equations to solve can be very complex. So 2/3 times a 4th, I get 2/12. 2/3 times this 2, I'm going to have minus 4/3. 1/5 times 4/3, I have 4/15. And then 1/5 times 1, I get 1/5. Now, if fractions aren't your thing, my best suggestion for you to do is to change these to decimals. This is 0.167x. 4/3 is 1.333. 4/15 is 0.267, and then 1/5 is 0.2. So if I wanted to add 1.33 to this, add 1.333, I would get negative 0.2 plus 1.333. I get 1.133. Now if I want to subtract 0.267x, subtract 0.267x, I get negative 0.1x. So if I divided this by negative 0.1, divide by negative 0.1, oops, did that backwards, I would get x equals 1.133 divided by negative 0.1, I get negative 11.33. And the answer I get the closest to is choice number 4. For number 23, which quadratic function has the largest maximum? Well, the maximum is the highest y value of the graph. I put both of choice numbers 1 and 3 in my calculator, and then when I graph, this is what I get. If you notice, both of their maximums occur at 5, 5, and 5. The maximum of choice 4 is like 3-ish, so that's definitely not it. Well, how can I do this if all 3 of these are 5? The problem is with a parabola is that if you're graphing these points 0, 3, 1, 5, 2, 5, 3, 3, a parabola is never going to go up and over flat like that. It's always going to have one point in the middle that's even higher. So this is actually quite of a tricky question. It's choice 2 because there is a number, probably 5.25 or something in between, that actually goes higher. The maximum occurs at 1.5. Number 24, which statement does not correctly interpret voting rates by age based on the given graph? Which one does not correctly interpret? The answer is choice number 2. From 96 to 2012, the average rate of change was positive for only 2 age groups. So the average rate of change, remember, means slope. The best way you can calculate it is from 96 to 2012. If you were to draw a line connecting those 2 points, would it be going up? For this one, this age group, do you see how it went from 56.9 to 59.5? Still positive. 68.2 to 67.9, that one went down, but 69.1, this is actually positive for three age groups. So again, to calculate the average rate of change, what I suggest doing is taking a look, connecting the 2 points at the end, and seeing, generally speaking, if this line went up. And it did, because it went from 56 to 59.5.